Alright, here's a first example of trying to convert something from standard form to vertex form. Okay, so we're given an equation right here that's in standard form, so it's a relation in standard form, and it's asking us to transform it into a vertex form. Then afterwards, we can easily state the axis of symmetry, extract the vertex, and actually get the mapping notation and graph it and describe its transformations. That's the advantage of vertex form. We can't do any of this without it being in vertex form. So again, if we want to take a look at this, standard form is ax squared plus bx plus c. That is the general form of any standard form quadratic here. And we also want to write, we want to convert this into a vertex form, which is a bracket x minus h all squared plus k. And so the very first step that I like to do is find out what's similar between these two things. It's that a value. We're going to get the a value extracted out from standard form to vertex form. Okay, so what is my a value in the standard form here? What's that value in front of x squared? So the coefficient in front of x squared is 1. So the very first step I'm going to do is I'm going to extract that 1 out. And you see how that 1, this a is only a factor of these first two terms. It leaves the last numbers out here. So I'm going to factor out a 1 from the first two terms only. So 1x squared plus 2x, and put a bracket here, plus 5. And so this is kind of looking like vertex form already. I've got the brackets, I got the a. The only thing I'm missing is that square value, which is outside. My square value right now currently is on the inside. I need to do something to get that square value on the outside. And that key is to change this into a perfect square trinomial somehow, without changing the actual parabola here. Okay, so what we're going to do is I'm going to create a perfect square trinomial by adding a number here, because it's right now it's not a trinomial, it's only a binomial. So I'm going to have to add a number here in order to make it a trinomial. And to find out what number that is, there's a relationship between the b and that c value in order to make it a perfect square trinomial in the previous video. So remember the relationship from b to c. To make a c value, that's a perfect square trinomial, c is equal to b over 2, so you take half it and square it. That's really all you're doing. You're taking that b value, you're halving it and squaring it. So I'm going to take that b value, which is 2, so b is 2 right now. I'm going to half it and square it. So 2 divided by 2 is going to be 1 squared, and 1 squared will be 1. Okay, so I've created a perfect square trinomial. However, I've kind of broken a rule here. I've said that this is a quadratic, which equals to this, and this is supposed to be equal to this. This is what it means by putting one below the other, that all three of these statements are equal. But by adding 1 here, I've changed it. So to ensure that this is the exact same equation, I'm also going to subtract 1. So this is still equal to that, right? Now the problem is that this is no longer a trinomial. This is like a polynomial with 4 terms. So I'm going to have to take this outside the brackets here in order to maintain this as a perfect square trinomial. So to take things out the brackets, you have to multiply by what numbers out here. In this case, it's a 1. I'm going to write 1s like this now. That's how I normally do it. Alright. So I'm going to take this outside the brackets. I'm going to multiply by 1. So 1 times negative 1 will be minus 1 plus 5. And now we have a perfect square trinomial. What two numbers multiply with 1 and add the 2? It's going to be 1. And minus 1 plus 5, I can simplify this. It's 4. And x plus 1 all squared, it repeated twice, so I can just write this out as a square. And now I have solved that original problem of getting that square value on the outside. We have successfully converted from standard form to vertex form through creating a perfect square trinomial. So that was a lot of steps. We're going to summarize now. To summarize, please follow these steps that I'm going to write here. So the very first step is summary. Factor out the a term from the first two terms. So here's the question. The very first thing we did was factor out that a term. So the a term in this case was a coefficient of 1. And so we factored out from the first two terms. So the first two terms are right here. So you only put brackets around the first two terms and you factor them out. So we factored out that a. Next thing we did was we halved b and squared the result. So in this case, b was 2. We halved it and we squared it. Oopsies. So half b squared the result, and this is the result that we got, which is a 1. And then the next thing we did is we took this 1, which is the result. So that value from step 2, which is a 1, we added it and subtracted it, which is right there. And then step 4 was to distribute the last term out of the brackets. So we gotta distribute the last term out of the brackets, which is this term right here. 1 times -1 gives us -1. And so that's distributing the last term out of the brackets. And so we get one perfect square trinomial, and we can factor that, which is this part right here. Factor out the last perfect square trinomial. And now we have a final result of something that's the vertex form, which is exactly this, x minus h all squared plus k. So we've completed our goal of converting from standard form to vertex form, and now we can actually answer the question. We can state what the axis of symmetry is. So let's go back to a pen here. Do our therefore statements. Therefore, axis of symmetry, I'm going to write AOS, is x equals -1, right? Remember, change the sign, that's -1. The vertex is going to be -1 and 4. Remember how this is moving to the left 1 and up 4, according to our transformations. And the mapping notation. The mapping notation is x comma y, so that's every x and y coordinate of our parent is going to be transformed according to this transformation, which is a, h, and k. So all my x values are going to be moved to the left by 1, so x minus 1, and the y values are going to be multiplied by 1, so the y values are going to be not stretched or compressed in any way, and they're going to be moving up by 4. And there we go. This information here in standard form is you can't extract this axis symmetry or vertex or mapping notation in standard form. You gotta convert it to vertex form, and then we can get that information. Okay. So there you have it. You've got the basics of completing the square.